Now, to model a steel girder bridge, the steps are almost the same, with the difference that now we have to add more elements to it, right? Like steel bridge may have cross frames, stiffeners. So the steps are the same. We need to add a bridge, place support lines, again indicating where the piers and abutments are. We place the deck. We do the beam layout, right? And then we place beams. Now, in case of a build-up beam, we need to define the width and the thickness of the top flange, bottom flange, and the web. If there is any variation along the length of that beam, it's a little bit different. So we will cover that as well. To place beams. And then, of course, we need to place cross frames, different types, B shapes, X shapes, stiffeners along the cross frames as well. And when the full superstructure is built, then we can place piers, then we make room for the bearings, and then we place the approach slabs or any accessories like luminaires that can go into the bridge. So to follow that steps in a nutshell, this is what we do. We have again, this is our Bristol Girder bridge, but then we're going to place our steel bridge. And that steel bridge could be on a straight line or could be on curve. Well, we don't make a difference to the software for that. So it's just a matter of placement. So let's place the bridge. So we place the support line. Since we're using the alignment and profile, you recognize that is under or along the curve. So we're placing that. There is no limit on the number of steps or spans, sorry, that we can do, right? Or the separation. So we just have the spans there using a predefined template. We place the deck. Remember, these templates could have variables, so it could be a constant width, of course. It could be a variable width. It could be just a normal cross the slope, or it could be in super elevation. So the template has variables inside in which the user can customize and define, as we're doing here. It's of a different width. So the template is created in such a way that accept these variables that we can modify. And we just have the deck. So the next step will be to place the girders. So, but before we need to define the layout, the separation between the beams, how it's going to be placed. So this beam layout, it's could be the same or could be different along every span. Usually try to be the same. So we create that beam layout. Different separation, different number of beams. We can flange one of the beams or flare one of the beams as well. So it's just all dialog box driven. So of course we're going to go into great detail about how to define every single variable here. We copy that same layout to all the other spans along the bridge. So let's do that. Copy the same layout. Validate our design so there is no red flags. So save it. So we got the beam layout, as you can see. It's at the bottom. Yes, kind of a construction line defining where the beams are going to go now in 3D. And that is the beam definition. As I said before, we need to define the width, the thicknesses along the beam length of all the different elements, or in this case, a build-up beam. We can have a graphical interface that help us in defining each one of the elements, the web, top flange, bottom flange, and so on. We create that design for one beam, and we can just copy that same geometry to all the other beams of the bridge, unless there is different, right? So let's define all of that. Okay, so now following that beam layout at the bottom, it's going to place the beams under the deck. Let's do that. Let's place, and then we can review that structure, as you can see. Okay. Next step is using the library of cross frames that we provide in the software, or you can customize as well. So we select what type of cross frames we want to place. As mentioned before, we can have B configurations, X configurations, or you can create your own custom configuration. Specify the type of steel elements that are going to go. You can create it as well using built-up plates. Uh, or specify the geometry, their location, if there is any gusset plates connecting these elements or just welded. And then as we create the cross frame or cross frames that we want to place, so it's a matter now of using our cross frame wizard to be placed along the bridge at different configurations, different spacings, uh, and separations too. Right, so we could be very precise into that. So we're going to cover that as well in great detail. So we just here placing it, and it's going to be placed and adjusted along our bridge. Right, this is the wizard I was talking about, all the different configurations. And we can have different spacings based on distance, based on stationing. So, and the method of placement or getting more detail depending on user specifications for every release that we have. So there's always new requirements that we are just happy to introduce into our software to make the 3D modeling more and more uh, easier to do, I would say. So now the cross frames are placed. They don't need to be the same. They could be different. We can have diaphragms at the beginning, then regular cross frame, another diaphragms at the piers. But then the geometry is adjusted automatically here. So I got my steel bridge done.